Okay, Asmui, I think you will handle the participants. I will start the on the simulator. Okay. So continues for that day. We finished doing the millings. Today we will do turning instead. Okay. So for those who want to get the simulator, the trial for simulator, can refer to me or your. For those students, you can refer to your lecturer on how to download the trial if you want to try. Okay. So today is a turning demonstration with a Fanuc controller. Okay. As you can see, we we call this the launcher, the software launcher is the same. Okay, so just pick the Renan CNC launcher and go to VM. Here you have to choose OITF. Is the model, the controller model for Fanuc. Okay. After it launch, you will have this interface. The interface is similar to milling. We have a panel here, the control panel at the bottom right, and the controller panel on the top right side. For the left side, we have the view options. Okay, this one is just to control the view, and a zoom option.
Tengah buat masuk.
You can also hide the machine case.
Team.
Yeah, who is speaking? Okay, we can hide the case. This one is a two setting display state. Stock measure, so we can measure our stock diameter. This one is to show the section display when we want to do internal turning. Okay, so this one is just to control the view options, zoom options, more on the display purpose. On the top side here, the first one button is resume to default. So as you can see, my setting here right now is already customs. Okay, if I click on resume to default button, restore initial data. So every setting will resume back to the software initial state. Okay, save the current work files data. It will ask you to whether you want to save your current setting. Okay, if you click yes, then you can save the current setting. Okay, if you just click import, then everything will back to the initial state. As you can see, the geometry offset is already setting back to the default value. Okay, right to it, we have the turret tool setting. Okay, here we can customize the current turret using on the simulator. Okay, so the turret is a 12 tool turret, and we can install 2 if we want, or we can modify the turret. We can also export the turret so that we can have an additional turret that match to our real machines. Okay, you can also import after if we have another turret to bring in. Tool trolley is the functions that we can store our tool. Let's say I want to store a center drill. 1.5, select. if I store the tool inside the tool turret, I can add the tool. For example, I want to install tool on tool 12. I go to install tool. It will pick the tool from tool trolley. Okay. Then you will have a new tool on your turret. Next to the turret setting is the material setting, in which we can adjust our material to based on our exercise or the subject we want to simulate. Okay. Next to it, we have the simulation speed control, in which we can adjust our simulation speed to speed up the simulation process. The real one is the real speed. If we click the real speed, then the machine will run in the exact same feed rate that we're setting. So it's more close to the real environment. Okay. And up here, we have a few different tools to control the software. Okay, we have the file. We can import the configuration of machines. We can also import our material. You can also import the CNC file if we have. Okay, to bring in so that we can simulate from your the NC program that you create from your CAM software. You can bring in. Later, I will show how to do. Okay, interface here is to control the interface. CNC control panel minimum. You see, it will control the interface of your controller. So it's actually the same functions if we click on the icon here. Okay. And also we have a machine operation panel. Okay, this one is the full operation panel. By default, it will show the modular design panel. This modular design panel is a significant thing in this software because the developer designed it as it in a modular design, because if we choose different mode, you will see that only the necessary key feature will be shown. The developer hope that this kind of design will help student or user to quickly recognize which buttons to use whenever they're changing the mode. Okay, to speed up the learning process and also shorten the time to remember that the necessary key we want to use when we go into different modes. Okay, I will talk about this more later. Alright, so interface is to control the interface. View is the similar things to the view setting here. Tool setting is the same as here. Okay, we can also add on our tool library so that we can add the tool later into the tool trolley that we will use it to put the tool into our turret. Okay, we can also adjust the mouse setting here, but this one is not that necessary for those expert users. Maybe they can use. Also, you can set up the software preference. So there's pretty much everything I want to cover on the top parts. Now let's back to the controller panel here. Okay, I will just hide the controller first. Let us focus on the machine control panel. Okay, here this one is a modular design. So on the most right part, we have the button to control the feed rate, the rapid, spindle, override, and a turret setting. This one is to setting the turret index. Manual turret index. Some machine have this, some machine maybe don't have this feature. Okay. So as you can see, when I try to switch into different modes, the key setting here will automatic display whenever what is needed in this mode. For example, when we're using a jog mode, we were using the working feed rate override and also spindle override most of the time, so that it will show it. When we go to rapid, it will automatically close the unnecessary things, because when we go to rapid, we only control the rapid override knob. Okay, so to control the percentage of feed rate of machines. When we go to MDI, instead we have cycle start and single block buttons to control the program. Okay, so this design is I think is very user friendly and is one of the specials on run simulator software. Okay, back to the controller here. We have two different screen. One is the full screen with the soft keypad that we can type in our program later, and a short one, okay, and a mini one that we can only showing positions, program, offset, and message, and also reset buttons. Okay, this one is also useful. One is you can save the space for simulation and also hiding unnecessary keypad when we are not using it. Okay, now let me introduce some of the functions on the different mode. Okay, the first one is the 0, in which we will set the machines back to its machine's origin. Okay, normally this one you have to go to positions in the controller display here. Okay, in position we have three different screen to show the coordinate of machines. We have absolute. Okay, so this one is same like milling. Absolute is normally based on our program. Relative, and also this one actually is all display. We can see the machine display here. Okay, so when we go to 0, back to machine reference positions. So first we have to go on x-axis. Okay, so this one will show 0, and then the axis. Next we have rapid. Okay, in rapid mode, we can control the axis. If we have alarm, click reset to reset the over travel alarm. Okay, the rapid override will control the speed of axis moving. If 0, it will go to the override will be the lowest speed. We have the feed control here to control our feed rate, because sometimes we need it to adjust our speed whenever we want to do some measurements or to travel. Okay, for safety purpose, so that we have a different kind of override. And we have jog. Okay, the same thing, we're using the key here to control the axis. Okay, and by the override, we can adjust the feed speed, the speed of axis moving. Okay, this one is to control the RPM. In the top, reverse. Okay, normally we're using the forward direction, which is this key. Okay, then we have another mode of jogging our machine. Is called using handle. Okay, so handle we have three different increments: 1 micron, 10 micron, and 100 microns. 100 micron is 0.1, 10 micron is 0.01, and 1 micron is 0.001. Okay, as you can see here, it's only moving 1 micron. Okay, you can use your mouse to drag the hand wheel to indicate the motions, or you can use your mouse third mouse to scroll, so that you can rotate the hand wheel more easily and smoothly. Okay, so here you can select the axis that you want to jog using the hand wheel. Then we have MDI. So to manual data input, we can input our program. Let's say I want to make a spindle on, so we just go to MDI. S 1000 M3 EOB insert. This is how you start the spindle using the NC code, and then go to cycle start. To stop the spindle. Then you can do two changing, 0, 1, 0, 0, EOB, insert, to do two change. Okay, so those are the basic commands. I think this one lecturer will teach in the class. Okay, next we have auto. Auto, when we want to run the program. Okay, DNC is not using in this simulator, but in real life, DNC allow you to run the program remotely from the controller. Means that we are using an external source. For example, maybe you have this CF cards installed in your controller. Then when you want to run the program, you can use DNC. So the program will run directly from the CF card. Or you can link it to your computer so that the program is running from your computer directly. That's we using DNC. But in this simulator, we don't have such functions because simulator is still on a software base. Okay, then we have edit, so that we can edit our program. Okay, so for Fanuc is quite simple to remember. Normally when we going to job, we will most of the time reference to positions and also offset, because we want to do the two length compensation settings. So it's most related to our positions. So usually on this 4 mode, we will only using position and offset most of the time. Then on MDI and edit or auto, we will focus more on the program. Okay, so it's for those who are not familiar with Fanuc controller, you can take this as a kind of a hint, so that you won't keliru on what to pick on the screen. Okay, so program, for you to edit program, you have to go to edit mode first. Don't go to auto, you have to go to edit, then you only can do a program here. Okay, now we back to the program screen. When we click the program button, normally you will have two options will be displayed. One is called the directory. Also, we can click the button here, the bottom soft key here, so that we can view all the program we have. If we click again, it will go into the currently program selected. Okay, how to know which program is selected? You have to identify it with this icon, the alliance icons. Okay, usually we will pick from here and choose it at main, then it will become our program. Back to program, it will become 6525. Okay, or in a quick way, you can just type in the program number 6524 maybe, then press the down button. It will go to the 6524 program. Okay, let's say you want to create a new program, you just need to key in the O and your new program number, press the down button. Okay, program not found. Sorry, it's not here. We have to go to directory 00100. Sorry. Can you help me to pick up the phone? Okay, just go to program screen. Directory 1011. number not found. Oh, yeah, we can oh 1011. I will back to this later. Okay, let me show you the auto first. Check. Then cycle start. Yeah, because we changed the setting just now. Okay, little mistake here. Restore initial data. No. Okay. Just reset back to origin. Auto. Cycle start. Okay. Okay, here we just put it put here. Then
Oh, ada dah. Oh.
can you
Ni.
hear my voice? Uh, uh, uh,
Aku tadi pun kan, kan tadi. Buat aku nak telepon tak ni?
okay. Now the program is finished. Okay. Let me back to how to create a new program. Just now I forgot the step actually. Okay. To create a new program, you have to go to insert. Okay. So if write protected, because you have to turn on the protection key. Okay. So let's go to program again. 01011. Then you can press insert. Then you can create a new program. Okay. So this is what we can do with our program. So to do a program, you can just press here. Don't press on your keyboard because it won't have any function. You have to press exactly on the virtual controller. Okay. But what I suggest is that normally you can just use a file import. It's a much more easiest way to do a program. But let's say if you want to practice the programming feelings on the controller, it's just best that you using the control here, keypad here, to key in your program. Okay, so that you get the real feeling on how to key in the program manually on the real machines, because you have to use it on the controller. Okay. Now, let me change the settings so that we can, let's say I want to do the setting based on my design. Okay, so this is a SproCam. It's the cam software that I'm using. Okay, so today we will do the simulation and tool setting based on these operations. It's just a very simple operation here. Okay, first of all, let me check the tool that we needed. The material, the workpiece size. Okay, so the diameter is 50 and the total length of our product is 65. Okay, so right now I just go to material setting and change the diameter to 50. Our length L1 here, since our L2 need to be 65, so our length should be longer. You can go to 120 if you want. L1 indicate the portion of material is within the chucks, so we can maybe within 40. Okay, so this one will change the material. Next thing, we have to identify the tool we are using. Okay, in my CAM software, I'm using the tool that is exactly the same as on the machines. So I'm using a rhombus tool and also a triangle tool for finishings. So here I need to check back on the turret. Okay, this message will come up if our turret is too close to the chuck, because in real life, when you want to do tool change, this one should be retract to a certain safe distance. So this message pop up, it will let you know that please move the turret position to avoid possible collisions. So it's a safety reminder. Anyhow, when you go into here, we can check the tool we have. So tool number 1 and tool number 2 is what we were going to use: external roughing and finishings. So we will do 2 offset using this tool. Okay, first of all, I want to let you know that by default the simulator setting is using you can see that the tool length is a little bit different, that we want to set it up later, because the default simulator system using this one, we call it work shift. Okay, to do the things. Okay, so by work shift is a advanced tool offset options, but I won't cover it on today topics. Today topics will more focus on the basics tool settings. Okay, so let us clear the setting here first. Just pin 0. Okay, offset, we will need to back to find the work shift you want to clear off, because you're starting on this default setting. You just go to offset and click the arrow button here on the bottom left. This one we call it the bottom soft keypad here. Just press the button here and go to the shift value. Okay, and clear it to 0. Then you have to back to the work set, and we are focusing on this geometry. Okay, so we have to change tool number 1 and tool number 2 X and Z value. Okay, using the most basic and traditional way of tool offsets. Okay, so let's start. Here we have to go to 0. Okay, then you can repeat. Oh, now I'm on tool number 2. It's okay. We can use tool number 2 to okay. We have to turn on the spindle. Some people comment that whenever the machine started to make noise, yours cannot hear my voice. Is it? Let me check whether I can mute the machines. Preference, sound control. Just try the sound. Hello? Can you hear my voice? All right. Okay, so the spindle is turning now. Okay, right now I want to find the, let's say I want to find the Z first on tool number 2. Okay, so right, I want to do this offset. Okay, when you near to the machines, it's better you go to top view. Okay, because in front view you can't actually really see that tool. I know this is not actually the same like in real machine when you do the settings, but in a way of using the simulator, you have to go to the top view. Okay, so we will using a handle to jog our tool. Okay, x-axis going down, then Z, zoom a little bit closer. It's not cutting. Okay, so we cutting down. Then you can jog back up. So now you have to go to offset tool number 2, because I'm right now using tool number 2. Okay, and we will key in Z0 dot measure. Okay, it will pinpoint the current direction here as the 0. Okay, you see here the value here is actually reflecting to the machine's coordinates. Okay, so don't confuse which value you want to use. Okay, you can also input by keying directly the digit using input. Okay, the quickest way is using Z0, then you click measure, so it will capture directly. The system will capture directly by the commands. Right now I want to do the X, so your X should go down a little bit, and you have to cut through the Z axis. Okay, then you return back. Stop the spindle. Then take on your caliper. Okay, in real machine, maybe you have to use a micrometer screw gauge. Check the diameter for 9.841. Okay, remember this value, diameter here. Go to the x-axis, tool number 2, and press X for 841, and hit measure. Okay, so 255.741. The value is already captured. Okay, right now let us check whether this value is correct or not. You can go to MDI, go to program. Wait, let me jog a little bit. further. Then go to MDI. Okay. You have to call the tool again. P0202 0P start so that it can update the latest setting. Now back to your program. Okay, G00. Let's say I go to Z 10 POV, insert, like a start. Now I try to jog down. You can use rapid or jog, up to you. But in real machines, normally we will use handle. Okay. So no collision. Indicate that our setting is most of the time is correct. Let me try to check whether I can use the length here to check the distance. Okay, seems not working here. Sorry. Okay. Then I try to go to 0, G00, Z0, cycle start. Okay, so seems is correct. Okay, okay, so Z is correct. Let me check about the X. If I go to 0, this one should be on the center. Alright, so here, this is how you set the two offsets. We have two number one to set, so right now let me retract and MDI T0101 will be cycle start. Okay, 201. We have to do the same things again. Go to the rapid. Okay, bring your tool closer to your material. Turn on the spindle. Go to handle. Jog. So if the tool is touching your material, it will turn to red color. Okay, indicate that the tool is cutting. If you are turning too fast, okay, because you are jogging too fast. Okay. So okay, turn again. We should actually using a lower feed. Okay, but anyway, this one you need to retract out because we already cut it. So same method, stop the spindle, measure 5 meter, 49.292, offset, tool number one, X 49.292, measure. Okay. Next, you have to find the Z. I have to do it again. Okay, program offset. Oh, sorry, check Z0 measure. Okay, this one we track back. Stop the screen. Okay, we have set up the tool. Right now we can import our program. So this is the end product. Should be look like this. Okay, program. File, Cnc File Import. Let me delete this program first. Okay. Then here on the left side is the directory on your computer. So you can choose the extension of that file. Mine is NC. So 2804 is my program. Import. Okay, it will be right here. Make sure when you import, you have to also turn on the program override. Okay, make sure it's on. Okay, right now here 2804 we have bring in. You can go to edit. 2804. Select. Okay, we're checking. So this one is actually wrong. This one should be M03 author. Okay, we can find another M to make sure that this one is correct. M03. You can go to the search. You can using the search button. Search down. Holiday search down. Okay, so it's only I have to source M04. Search down. Okay, so this one also need to change. Auto. Yeah. Then just press reset. Make sure that the header, the highlights back to the header. Then you can click check. Go to auto. You can also back to home position if you want. Okay, let us go to auto. Maybe I try to run on single block. So you will run line by line. Okay, home position T01. Turn on the spindle. Okay. Slow down the simulation speed. Okay, so we go to Z0.294. Traction. Second cut. I can now turn off the customer block. So there's a collection here. Okay, so to check what is the problem here, we can check back. Maybe it's our cam problem. Okay, or maybe it's the tool problem. So from the simulator, we can know what might actually go wrong. Problem. Go to here. Okay, never mind. Let me reset back. Material setting, set back. Okay, let me try to do again the tool setting. Okay, let me just turn on the spindle. Now I'm using tool 1 to do a measurement again. And okay, offset, set 0, measure. Track. Now the do measure x-axis. Yeah. Touching. Okay, set. Go forward. Just go slowly. If you go too fast, it will generate alarm. Software is quite sensitive. Okay, then you have to jog back. Stop spindle. Measure 49.105. That's 5.105. Measure. Okay, seems like nothing changed. Change to tool number 2. NDI 20202. Cycle start. Spinner on. Spinner on. Okay. Not on, so I have to manually key in the spinner on command. Okay. Go a bit slower. Okay, so we have our jack set. Jack 0, entry. I'll do the F. Jack. Stop spinner. Check. Okay, just now I forgot to mention, right click to get the diameter. 49.008. X4 5.00. Okay. Measure 255.7. Okay. Back to the 0 again. Go back to auto. Rewind. Side start. To number 2. Okay, finish process. Yeah, the end part is not cut because the part is 50. Okay, that's why it's not cutting. 24, 54, 50. 54, 24,